أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم Assalamu alaikum wa rahmatullah, and I welcome you all to the channel today. Today we will explain projectile motion. Our aim is to give the explanation to the concept of the projectile motion. We may not necessarily solve problems related to projectile motion, but we will try to bring to light the concept embedded in that motion. What kind of motion is projectile motion? What are the relevant terms used in projectile motion, and what are their meanings, so that when we start solving problem, we know what quantity should we use, what are the equations we need, what are the conditions that we need to keep in mind while solving projectile problems. Okay, as you see it written here, let me explain what we have here. They said projectile motion is the motion of an object which is projected into the air and then follows a curved path under the influence of gravity. Okay, let me explain that. Any particle, any object you throw into the sky, or you release from a height, and it falls under the influence of gravity, meaning the only force acting on that object is gravitational force. Okay, gravitational force is the only force acting on it, then that object is a projectile. If I have a ball and I throw it into the sky, that ball is a projectile, and the motion of the ball, we call that motion projectile motion. If you are a footballer and you have taken a free kick, you kick the ball and it approaches the goal post, the ball in air is a projectile, and the motion of the ball is a projectile motion. If a person has thrown a javelin, there is a game javelin throw. When you throw that heavy metal and it is in air, that metal becomes a projectile. Okay, if a bullet is fired, the bullet moving in air before reaching the target, it is a projectile. Okay, because the force acting on the bullet is the force of gravity. Even though we know there are air resistance, we neglect the effect of air resistance. We know because in the lower atmosphere, for example, we have air molecules, and any object you throw into the sky, its motion is affected by air molecules. It is attacked, bombarded from all sides by air molecule, and this is why a projectile will follow a curved path. Okay, the object is called a projectile. I explained that the object you throw into the sky is a projectile, and the path it follows is called its trajectory. Its trajectory is the path. It's like the road of the projectile, okay, in the sky. Where it actually follows is what we call trajectory, and that object is a projectile. The motion of the object is called projectile motion. Then they say projectile motion is a classic example of a two-dimensional motion. It is not a motion along a straight line. If you have a car moving on a road, okay, we call this motion, the motion of the car, motion along a straight line. It's one-dimensional motion because you only have it along the x-axis. Okay, but for projectile motion, it is both x and y that are involved, meaning a projectile can cover, for example, vertical distance. It can also cover horizontal distance. So you have vertical component, you have horizontal component. Again, a projectile has vertical velocity, it has also horizontal velocity. So you have two components. Any velocity that you have for a projectile, you can resolve it into a vertical component and a horizontal component, and this is the reason for saying that it is a two-dimensional motion. It is a type of motion which is governed by two independent components. You see, one component is the horizontal component, the other component is a vertical component. Okay, and we do not combine vertical velocity and horizontal velocity in one equation. It does not make sense at all. If we are analyzing the horizontal motion, then all our velocities must be vertical, okay? And our distances must be vertical distances, the height. If we are considering and analyzing the horizontal motion, then our velocities, our distances must all be horizontal distances. We do not join the two together in a single equation. This is a mistake. We need to understand this clearly before we start solving problems. To be able to establish equations of projectile motion, we have to give the general case of a projectile. Okay, let me draw that and explain. Okay, now okay, this is the horizontal. This is like our x here, the x component. Then we also have the vertical component. This is our y. Okay, so the horizontal is two-dimensional, x and then y. So if I have an object here, okay, it can be a ball, it can be a bomb that you will attack an enemy with, it can be a bullet, for example. But let us assume it to be a bomb that you send during warfare, and you want to attack the enemy. Then the ball is the bomb is projected in this direction. Sorry, I have to use this one. Is projected in this direction, and then it has initial velocity. The initial velocity is u in meters per second. This velocity is in meters per second. You can see that this velocity is inclined. It makes angle theta. It makes angle theta with the horizontal. And in our study of vectors, we know that velocity is a vector. In our study of vectors, we say any vector that is inclined, this vector has component along the vertical, okay, and it has component along the horizontal. Its component along the vertical is you take the magnitude of this multiplied by the cosine of this, and its component along the vertical here is the magnitude of this velocity multiplied by the sine of this angle it makes with the horizontal. Okay, it means that our velocity has both horizontal and vertical component. The horizontal component along x is generally called u sub x. And how do we get u sub x? We take this u and we multiply it by the cosine of this angle theta, and the component of this u along vertical axis here, along the vertical, is generally called u sub y because it is along the y axis. And how do you get its component? How do you get its magnitude? You take the magnitude of this velocity and you multiply it by the sine of the angle it makes with the horizontal. You see that? Now, if you launch it, okay, because there is force of gravity on it, it will not follow this path exactly and follow this line. It will not move along a straight line. The gravity will make it bend. So if it started from here, the influence of gravity acting on it will not make it follow this line straight. It will bend, and after some time the gravity overcomes it, and then it begins to come down until it reaches the projection plane again. So this is the path it will follow. It will follow this path, it will follow this path, and then get to this position. It comes back to the projection plane again. This horizontal plane, it is called projection plane, because this is the plane from which it was projected. Okay, you can see that as it is moving, it has, as we explained, horizontal velocity and vertical velocity. Now take this into consideration. Don't forget this one, that this horizontal component, this u sub x, is constant throughout the motion, when the projectile is here. Let's call its positions here. Let's say its position here is A, its position here, let us call it B, and then its position here, let us call it C. Okay, now at this position A, it has horizontal velocity. This horizontal velocity is the u sub x. At this position again, it has horizontal velocity, which remains u sub x. At this here, it has horizontal velocity, which remains u sub x. And even when it reaches the projection plane, it still has horizontal velocity, which is u sub x, and it is constant. If this u sub x is 30 meters per second, for example, then it here is 30 meters per second, here is 30 meters per second, here is 30 meters per second, here is 30 meters per second till the end of the journey. It does not change. Now, one will rationally ask, of course, you can ask, why does it not change? And the reason is that the change should be due to an acceleration, and the only acceleration that we have is gravitational acceleration, and gravitational acceleration is vertical, is acting downward. You see, gravitational acceleration is acting downward, so it has influence only on vectors that are vertical, whether vertically upward or downward. But this velocity that you see is horizontal, so gravity has no influence on the horizontal motion. That is the reason. Okay, don't forget this. The horizontal velocity does not change. Why? Because gravity has no influence on the horizontal motion, so its influence is only on the vertical motion, and that is why the horizontal velocity does not change. But the vertical velocity will change. You see, this vertical velocity will, as it is moving here, your u here, this is u sub y, I can call it 1 here. At this, it will keep on decreasing because of the influence of gravity. And when it reaches B here at maximum height, then your u sub y is 0. Okay, is 0. Then when it leaves y, okay, when it leaves this y, the direction of u sub y will change, because now it is coming down. Okay, so the direction will now be downward. The direction will now be downward. So you have u sub y, I call this u sub y 1, let me call this u sub y 2, and this one u sub y 3. So the direction of u sub y before reaching the maximum height is upward. When it reaches the maximum height, u sub y is 0. Beyond the maximum height, after the maximum height, the direction is now downward. You see that? Downward. And at this position too, your u sub y, let me call it u sub y 4. Okay, so when it reaches the projection plane, you can see it has both the horizontal velocity and the vertical velocity. This is in this direction, and this one downward. So you can even find the resultant of the two. Okay, you can even find the resultant of this and this at the end of the motion. Okay, look at it here. This one here, we can draw a line here. You see, this will give us the maximum height. The maximum height is represented using capital H. Then you can also have an equation, of course, that will tell you its vertical distance at any given time. You can use this equation. Y is equal to this equation of uniformly accelerated motion that we know. Y is equal to um, u sub y t, okay, minus half gt squared. Okay, in case you are confused, I got this equation from this formula. S is equal to ut plus half at squared. Now S is the distance, and now our distance is vertical. If you are considering vertical distance, then it should be y instead of S. So I put y here instead of S. Then remember what we said. It has two component. You have vertical component of the motion, horizontal component of the motion. Since y is vertical, you have to use vertical velocity, not horizontal velocity, and this is why I have chosen u sub y and not u sub x here. Okay, u sub y t, and t is the time taken. Then I change this from positive to negative because it is going up. It is going up, so I have to use minus here. Then I have a half, my a changes to g, and then I have t here. So this is the equation we use to get the vertical distance at any given time. So after 1 second, if after 1 second, 1 second after the journey, I want to know how high above the ground it is. Okay, I will just substitute 1 here for time. Okay, and if I know g and u sub y, I will substitute that, and it will give me the vertical distance in meters. So when it has reached this projection plane again, the vertical distance is 0, so I can set this one is equal to 0, and this time becomes the time of flight. So you see, from this equation I can get the time of flight, the time for the projectile to have this complete curve here. I forgot to tell you that this curve part from here all the way to here is what we call trajectory. Okay, trajectory. Okay, we call this one trajectory, and the particle that follows this path is what we call a projectile. Okay, now let's say after t second, the projectile is somewhere here. After t seconds, okay, the projectile is somewhere here. So I can get its vertical distance, here. I can get its vertical distance. I can call it y. The highest vertical distance is capital H. Any other distance you can draw, it is given the letter y. Okay, so you have y. You can use this equation to get that value. Y is equal to u sub y t minus half gt squared. Now when it is here, not only does it have vertical distance, it also has horizontal distance. Look at it. I can draw it because it was here initially. When it is here, you can see this is the vertical distance, but it has horizontal distance as well, and we can call that horizontal distance x. We can call it x, and is drawn from here all the way to here. You see, this is my horizontal distance. Okay, the question is, how do I get this distance, this horizontal distance? Remember that distance or displacement, you can call it displacement, of course, since it is displaced from here to here. So the horizontal displacement is equal to, now we know that from this formula, there is a formula that says velocity equals displacement divided by time. So from here, your displacement is velocity times time. So do I write velocity times time? I have two velocities here. One is vertical, one is horizontal. So since this my distance x is horizontal, I will use the horizontal velocity. Remember when I was trying to get my y is vertical, so I have to use vertical velocity, use of y. So this should be my horizontal velocity, use of x, and then multiplied by the time. Okay, the time it takes is t seconds, so multiplied by t, so this is equal to u sub x t, and I know my u sub x is u cos theta, so I have u cos theta multiplied by t. Then I will now say u times this t, I will have u t cos theta. This will give me the horizontal distance covered at any given time. Okay, and this one will give me the vertical distance covered at any given time. Now what if it has reaches this position? When it has reaches this position, it will have the highest horizontal distance covered, and this highest horizontal distance covered has a name. We call it range, the range of the projectile, and is denoted by capital letter R. The range of a projectile is obtained when the projectile hits the projection plane again. Okay, the journey has ended, so you have your range. You see that? So it means range again, okay, is also equal to the horizontal velocity, which is u sub x, multiplied by, now the time will be time of flight, because when it has reaches here, the journey has ended, and the time taken, we call that time of flight, and is denoted by capital T. So you have u sub x capital T. Okay, now finally, what I want you to take note of is that the time taken by the projectile to move from here to here to reach the maximum height is the same time it will take to move from the maximum height to the projection plane again. It means if the projectile has taken 4 seconds to move from here to here, it will take another 4 seconds to move from B to this. Let me call this point D. If it takes, let me call this O. If it has taken 4 seconds to move from O to B, then it will take 4 seconds again to move from B to D. The two times are the same. So it means that if I know the time taken to reach the maximum height, and I want to get the time of flight, I will just take the time taken to reach the maximum height, which is usually denoted by small t, and multiply it by 2, and it will give me the time of flight. So it means my time of flight t is equal to 2t, twice t. This t is the time taken by the projectile to reach the maximum height here, okay? And then this capital T is the total time taken from here all the way to here, from O all the way to D. In the subsequent videos, we are going to take the time of flight, for example. We will explain it, derive its equation, okay, and solve problem related to it. Next, we will take range, explain it, derive its equation, solve problem related to it, and then we will now take the maximum height as well, solve it, derive the formula for it, and solve problems related to the maximum height. I hope This video helps you in understanding the motion of a projectile. If you have any question, if there is any point you begin to feel lost, please let me see that on the comment section. Ask your question on the comment section and I will check it and respond to you accordingly. Assalamu alaikum wa rahmatullah.